Question number 1. A company has an application that runs on Amazon EC2 instances in an Amazon EC2 auto-scaling group. The company uses AWS Code Pipeline to deploy the application. The instances that run in auto-scaling group are constantly changing because of scaling events. When the company deploys new application code version, the company installs the AWS CodeDeploy agent on any new target EC2 instances and associates the instances with the CodeDeploy deployment group. The application is set to go live within the next 24 hours. What should a solution architect recommend to automate the application deployment process with the least amount of operational overhead? Question number 2. A company is developing a new on-demand video application that is based on microservices. The application will have 5 million users at launch and will have 30 million users after 6 months. The company has deployed the application on Amazon Elastic Container Service on AWS Fargate. The company deployed the application by using ECS services that use the HTTPS protocol. A solution architect needs to implement updates to the application by using blue-green deployments. The solution must distribute traffic to each ECS service through a load balancer. The application must automatically adjust the number of tasks in response to an Amazon CloudWatch alarm. Which solution will meet these requirements? Question number 3. A financial services company loaded millions of historical stocks trades into an Amazon DynamoDB table. The table uses on-demand capacity mode once each day at midnight. A few million new records are loaded into the table. Application read activity against table happens in bursts throughout the day, and a limited set of keys are repeatedly looked up. The company needs to reduce costs associated with DynamoDB. Which strategy should a solution architect recommend to meet the requirement? Question number 4. A company has a Windows-based desktop application that is packaged and deployed to the user's Windows machines. The company recently acquired another company that has employees who primarily use machines with a Linux operating system. The acquiring company has decided to migrate and rehost the Windows-based desktop application to AWS. All employees must be authenticated before they use the application. The acquiring company uses Active Directory on-premises but wants a simplified way to manage access to the application on AWS for all the employees. Which solution will rehost the application on AWS with the least development efforts? Hello everyone, I am Rafa Saeed, and I'm thrilled to welcome you to another enlightening 591 Lab video. Today we will be focusing on AWS Solution Architect Professional exam. Whether you are gearing up for the SAP-C02 exam or you're a cloud architect or system admin, this video is designed to offer you invaluable insights. Before we dive into the content, we kindly request you to subscribe to our channel, give this video a thumbs up, and hit the bell icon. Your support motivates us to create more valuable content like this, helping you excel in your cloud journey. Today's session revolves around auto-scaling and code deploy, where we will explore their significance and how to set them up effectively. Following that, we'll review exam questions to ensure a comprehensive understanding. But before we proceed, allow me to offer you a brief overview of what 591 Lab is all about. 591 Lab is a top IT training and certification exam brand in China, Hong Kong, Taiwan, and Singapore. Our mission at 591 Lab is to provide our clients with exceptional exam preparation experience for certification in AWS, Cisco, Huawei, Aruba, Juniper, Palo Alto, and Fortinet exam tracks. Today we have exciting agenda lined up. First, we'll discuss auto-scaling, explaining key features and benefits. Then we'll discuss a continuous delivery and deployment of application with and without auto-scaling in the AWS cloud. After that, we'll do a practical walkthrough in a console to understand how it all works. Once we are done with that, we'll review the key takeaways to ensure comprehension. Finally, we'll wrap up by tackling some exam-style questions together. So let's dive in and get started. So, what is auto-scaling? Auto-scaling is a service provided by AWS that automatically adjusts the number of EC2 instances in a group to match the demand of your application. EC2 instances are virtual servers in the AWS cloud that can be provisioned and configured to run applications. Autoscaling helps ensure that you have the right number of instances available to handle the load on your application, whether the demand increases or decreases. This dynamic scaling capability allows you to maintain consistent performance for your users while optimizing cost by only using the necessary resources. The key features of autoscaling are dynamic scaling, which automatically adjusts the number of EC2 instances in response to change in demand or traffic patterns. Predictive scaling uses machine learning algorithms to forecast future demand based on historical data, allowing for proactive scaling. Scheduled scaling allows you to schedule changes to the number of instances based on predictive traffic patterns, such as daily or weekly spikes in usage. Step scaling allows users to define scaling adjustments based on specific thresholds for a metric, enable more granular control over scaling behavior. Lifecycle management handles instance provisioning, termination, and replacement, ensuring that your application always has the required capacity. Integration with CloudWatch for monitoring and collecting metrics, enabling users to set alarms and trigger scaling actions based on CloudWatch alarms. Fault tolerance automatically replaces unhealthy instances and maintains the desired capacity, ensuring high availability and fault tolerance for applications. Integration with other AWS services such as Elastic Load Balancer, RDS, and Amazon ECS, allowing for seamless scaling of multi-tier applications and microservices architectures. These features collectively enable users to optimize resource utilization, improve application availability, and automate the management of EC2 instances to meet the demand of dynamic workloads efficiently. The benefits of Amazon EC2 autoscaling are numerous, contributing to improved efficiency, reliability, and cost-effectiveness in managing EC2 instances. Cost optimization reduces costs by automatically scaling resources based on demand, allowing you to provision the right amount of resources at the right time and avoid over-provisioning. High availability enhances application availability by automatically replacing unhealthy instances and maintaining the desired capacity, minimizing downtime and ensuring uninterrupted service for users. Fault tolerance helps by automatically replacing failed instances and distributing traffic evenly across healthy instances, reducing the impact of failures on application availability. Automation helps automates the management of EC2 instances, including provisioning, scaling, and termination, reducing the need for manual intervention and freeing up resources for other tasks. Simplified operation provides a user-friendly interface and command line tools for configuring and managing auto-scaling policies, making it easy to set up and maintain auto-scaling configuration for your applications. Overall, Amazon EC2 autoscaling offers significant benefits in terms of scalability, performance, cost optimization, and reliability, enabling you to build and operate highly available and efficient applications in the cloud. This architecture represents a simplified continuous delivery process using code pipeline and code deploy. Application developer pushes code changes to the repository, which triggering a code change event. Code pipeline initiates the deployment process. Code deploy then deploys the code to the EC2 instance, updating the application running on the server. Overall, this diagram illustrates the flow of code changes from the repo to the deployment of the application on an EC2 instance. There is no auto-scaling group, meaning there is no built-in mechanism for scaling the number of EC2 instances based on demand. This architecture may be suitable for smaller scale deployments or scenarios where the number of instances remains relatively constant, but what if you require multiple instances to meet varying load demands and immediate replacement in case of instance failure? This is where auto-scaling becomes crucial for scalability and auto-healing capabilities. This workflow represents more sophisticated architecture that incorporates an auto-scaling group to manage the EC2 instances. All EC2 instances are part of an auto-scaling group, which ensures that the number of instances automatically scales up or down based on demand, traffic, or other metrics. Code deploy also plays a vital role here by deploying the code to the EC2 instances within the auto-scaling group. This ensures that the code changes are deployed on all available instances in the group, rather than just a single instance. Overall, this architecture with an auto-scaling group provides a more robust, scalable, and efficient deployment environment compared to the first architecture without auto-scaling that we have discussed. It offers greater flexibility, resilience, and cost effectiveness, making it well suited for deployments requiring scalability and high availability. Now, let's move to the console to implement continuous delivery and deployment of application using auto-scaling and CodeDeploy. Alright, we are logged into the console, and in this demonstration, I'll show you how to streamline your deployment process and ensure seamless scalability for your application on AWS. First, we need to set up IAM roles to grant CodeDeploy the necessary permission to access your AWS resources securely. So I have already provisioned two IAM roles, one for EC2 and the other one for CodeDeploy. Let me quickly show you. So this is for EC2. These are the permission attached to this role. So this is SSM manage instance core, which will allow system manager to interact with EC2 instance, and this permission is basically allow EC2 machine to get and list application stored in S3. So this one is another role which we are going to use with the CodeDeploy. So in this particular role, AWS CodeDeploy manage policy is basically attached. Alright, so these two roles are very crucial for the whole deployment process. So make sure before the deployment, you should prepare both roles in your environment. Alright, so next step, we have to create an auto-scaling group with launch configuration or launch templates. I've also provisioned an auto-scaling group in advance, so let me show you quickly. Alright, so this is my auto-scaling group. The desired capacity is currently 0, which I'll change in just a minute. And this auto-scaling group basically contains this launch configuration. So let me show you this launch configuration as well. This is basically the launch template which are associated with the auto-scaling group I just showed you. And this is the AMI ID. So I am assuming you are already familiar with the launch configuration or launch templates and as well as auto-scaling group. So I'm not going to create auto-scaling group and launch configuration and or launch template in this demonstration. If you want to also see the detailed instruction how to set them up, so you can see my previous videos as well. I have already uploaded a few applications into my S3 bucket. As you can see there, this is my bucket name, 511 Lab Demo App, and I have uploaded 2 sample applications into this bucket which we are going to use in this demonstration. Alright, so let's jump back to the auto scaling and change the desired capacity. We will use 2 instances, so let's set the minimum and maximum 2. Alright, so our desired minimum and maximum capacity is 2, and as soon as I update it, auto scaling group will start launching 2 instances. So let's click on update and jump back to the EC2 instance. As you can see, 2 instances are start launching. Let's wait for a while. Once both instances are provisioned, then we will jump on CodeDeploy. Alright, so both instances are provisioned successfully. Let's specify the name for identification. This is server 1. And this is server 2. Alright, so I have already installed CodeDeploy agent in the AMI that I use in launch template. But if you want guidance how to install the CodeDeploy agent, you can get it from this link. So I'm using Windows Server So I followed the instruction given there. As you can see, these are all the instructions I followed for deployment code deploy agent. You can choose operating system as per your choice and you will get the relevant instruction. Alright, so IAM role is attached to the both machine. As you can see there, this is the role I showed you earlier. So this is for EC2, and if we click on server 1, then the same role is attached to the server 1 as well. Alright, so everything seems to be set up. So now we need to deploy our application using CodeDeploy. Let's jump to the CodeDeploy. This is the CodeDeploy dashboard. We need to deploy the application. So let's create application. Let's name it of your choice. We are using EC2. So we are going to select EC2 on premises. You can also select Lambda and ACS as well as per your choice. Alright, so let's select EC2 on premises and create application. So the application has been successfully deployed. Now create a deployment group. Specify a deployment group name. Alright, so here we need to specify the role which we are going to use with CodeDeploy. We are going to use the second code which I showed you earlier. So this is the code which we are going to use in this particular deployment. So let's select it. These are the deployment type. You can choose as per your requirement, like in place or blue-green. If you want to deploy two versions of your application and want to serve both application for the time being, then you can select blue-green. Otherwise, you can select or you can just leave it in place. This is the environment configuration. So we are going to use EC2 with auto scaling. So we will select this option. If you're not using auto scaling, then you can select EC2 or on-premise instance as well. So as soon as I click here, I am able to see my auto scaling group. So this is my auto scaling group. Let's select it. This is the deployment setting. All at once means the application will deploy on all the instances. And if you have, for example, 4 servers and you want to deploy application on 2 servers at once, so you can select it from here or one at a time as well. So I'll leave it all at once as of now. We are not going to use any load balancer, so we will uncheck this box and create deployment group. Alright, so our deployment group is also created successfully. Now it's time to create a deployment. Let's click on create deployment. So we need to paste the application URL here. So we have to jump to the S3 dashboard. We are going to deploy this application first. Let's copy the S3 URI and jump back to the CodeDeploy dashboard and paste it here. If you want to specify any description, you can write it here. These are the additional deployment behavior setting, which we don't need to modify as of now. So let's create a deployment. As you can see, application installation is in process. If you scroll down, you can see all the details here. So currently, script is basically running in the backend and downloading the bundle as well. So this is the progress of both instances. You can track all the progress of your instances as well. Let's wait for a while. Application will be deployed in few minutes. You can see all the event details by clicking on view events. So let's click on view events. As you can see, this is the basically progress of the application deployment. So few tasks are still pending, which will be done in a few minutes. Alright, so deployment on one instance has been completed. The one instance is remaining. So let's wait for a while. Alright, so both instances are basically done and the application has been successfully deployed. So let's verify by browsing the IP address of each machine. So let's jump back to the EC2. Copy the IP address. This is the public IP address. Alright, so the application, the demo app has been successfully deployed on instance 1. Let's verify the second instance as well. So let's copy the public IP of second server as well. Perfect. So the application has been successfully deployed on both instances. Now let's deploy another application on the same instances. We need to jump back to the code deploy. Click on copy deployment. And now we are going to change this URL. Alright, so let's jump back to the S3. And this time we are going to use a different application, or you can say the version 2 application. Alright, so let's click on it. Just copy the S3 URL and go to the code deploy dashboard and paste it here. Alright, and we don't need to change any settings. So let's create deployment. Let's wait for a while. The application version 2 will be deployed shortly. As you can see, the application version 2 successfully deployed on both instances. So let's verify by refreshing the URL or the IP address. Alright, so this is the basically version 2. And let's verify the second server as well. Perfect. Somehow the logo is not loading, which might be we need to embed correctly. So this is not the issue. We can make the changes as per the requirement. So the version 2 is basically deployed successfully. This is what we want to achieve, right? Alright, so our uploaded revision application successfully deployed, and there you have it. So you have learned how to automate deployments with AWS CodeDeploy and auto scaling group, ensuring your application are always up to date and scalable. If you found this demonstration helpful, don't forget to subscribe for more tutorials on AWS and cloud computing. Alright, so this is it for the demonstration for today. So now let's jump back to the console. Alright, so here are some important key points to remember. Continuous deployment with AWS CodeDeploy integrated with EC2 auto scaling, you can achieve continuous deployment of your application updates, ensuring that your application is always up to date without downtime. Automate the deployment process with AWS CodeDeploy, reducing the risk of errors and minimizing manual intervention. EC2 auto scaling ensures that the newly deployed instances are automatically added to the fleet and the old ones are removed gradually, maintaining the desired capacity. Integrate AWS CodeDeploy and EC2 auto scaling with Amazon CloudWatch for monitoring deployment metrics and instance health. This allows you to track the progress of deployment, monitor the performance of your application during and after deployment, and trigger auto scaling action based on predefined alarms and metrics. EC2 auto scaling helps optimize cost by dynamically adjusting the numbers of instances based on demand. Combined with AWS CodeDeploy, efficient deployment process, you can minimize the time of resource required for deploying updates, further optimizing cost associated with managing your application infrastructure. By leveraging the capabilities of AWS CodeDeploy and EC2 auto scaling together, you can achieve efficient, scalable, and fault-tolerant application deployment in the AWS environment. Now it's time to solve some exam-style questions, so let's get started. Question number 1. A company has an application that runs on Amazon EC2 instances in an Amazon EC2 auto scaling group. The company uses AWS Code Pipeline to deploy the application. The instances that run in auto-scaling group are constantly changing because of scaling events. When the company deploys new application code version, the company installs the AWS CodeDeploy agent on any new target EC2 instances and associates the instances with the CodeDeploy deployment group. The application is set to go live within the next 24 hours. What should a solution architect recommend to automate the application deployment process with the least amount of operational overhead? Option A. Configure Amazon Event Bridge to invoke an AWS Lambda function when a new EC2 instance is launched into the auto-scaling group. Code the Lambda function to associate the EC2 instances with the CodeDeploy deployment group. While this approach automates the association process, it still requires setting up and maintaining the Lambda function and event bridge configuration. This is not the correct answer. Option B. Write a script to suspend Amazon EC2 auto-scaling group operations before the deployment of new code. When the deployment is complete, create a new AMI and configure the auto-scaling group launch template to use new AMI for new launches. Resume Amazon EC2 auto-scaling group operations. This approach could work, but it requires manual intervention and is more prone to errors, especially in a fast-paced deployment scenario. This one is also not the correct answer. Option C. Create a new AWS code build project that creates a new AMI that contains the new code. Configure code build to update the auto-scaling group, launch template to the new AMI. Run an Amazon auto-scaling instance refresh operation. This option involves creating a code build project to build a new AMI with the updated code, updating the launch template with the new AMI, and then performing an instance refresh operation to replace existing instance with instances launched from the new AMI. This approach automates the deployment process and minimizes operational overhead by leveraging AWS services. Option D. Create a new AMI that has a CodeDeploy agent installed. Configure the auto-scaling group launch template to use the new AMI. Associate the CodeDeploy deployment group with the auto-scaling group instead of EC2 instances. This option involves creating a new AMI with the CodeDeploy agent pre-installed, updating the launch template to use the new AMI, and associating the CodeDeploy deployment group directly with the auto-scaling group. This approach eliminates the need to install the CodeDeploy agent manually on new instances and simplifies the deployment process. Among the options provided, Option D offers the most straightforward and least operational intensive approach to automate the application deployment process. Therefore, the correct answer is Option D. Question number 2. A company is developing a new on-demand video application that is based on microservices. The application will have 5 million users at launch and will have 30 million users after 6 months. The company has deployed the application on Amazon Elastic Container Service on AWS Fargate. The company deployed the application by using ECS services that use the HTTPS protocol. A solution architect needs to implement updates to the application by using blue-green deployments. The solution must distribute traffic to each ECS service through a load balancer. The application must automatically adjust the number of tasks in response to an Amazon CloudWatch alarm. Which solution will meet these requirements? Option A. Configure the ECS service to use the blue-green deployment type and a network load balancer. Request increase to the service code for tasks per service to meet the demand. While this option mentions blue-green deployment and load balancing, it does not address the automatic adjust of tasks in response to CloudWatch alarms. Additionally, manually requesting increases to service code is not the ideal approach. So, this is not the correct answer. Option B. Configure the ECS service to use the blue-green deployment type and a network load balancer. Implement auto-scaling group for each ECS service by using the cluster autoscaler. This option involves blue-green deployment and utilizing a network load balancer, but it suggests using an auto-scaling group with the cluster autoscaler. However, the cluster autoscaler primarily scales EC2 instances rather than individual ECS service. This is also not the correct answer. Option C. Configure the ECS service to use the blue-green deployment type and an application load balancer. Implement an autoscaling group for each ECS service by using the cluster autoscaler. This option suggests using blue-green deployments and application load balancer for load balancing, and implementing an auto-scaling group with a cluster autoscaler. However, as mentioned earlier, the cluster autoscaler primarily deals with EC2 instances, not ECS services, so this is not the correct answer. Option D. Configure the ECS services to use the blue-green deployment type and an application load balancer. Implement service auto-scaling for each ECS service. This option correctly suggests using blue-green deployments and application load balancer for load balancing. Moreover, it proposes implementing service auto-scaling for each ECS service, allowing automatic adjustment of tasks in response to CloudWatch alarms. This aligns perfectly with the requirements. Therefore, option D is the most suitable solution that meets all the requirements specified in this scenario. Question number 3. A financial services company loaded millions of historical stocks trades into an Amazon DynamoDB table. The table uses on-demand capacity mode once each day at midnight. A few million new records are loaded into the table. Application read activity against table happens in bursts throughout the day, and a limited set of keys are repeatedly looked up. The company needs to reduce costs associated with DynamoDB. Which strategy should a solution architect recommend to meet the requirements? Option A. Deploy an Amazon Elastic Cache cluster in front of DynamoDB table. While Amazon Elastic Cache can help improve performance by caching frequently accessed data, it does not directly reduce costs associated with DynamoDB. Additionally, adding Elastic Cache may introduce additional complexity to the architecture, so this is not the correct answer. Option B. Deploy DynamoDB Accelerator, configure DynamoDB Autoscaling, purchase Saving Plan in Cost Explorer. DynamoDB Accelerator can improve read performance by caching frequently accessed data, reducing the need to read from DynamoDB. This can potentially reduce DynamoDB cost by lowering the number of read capacity units consumed. Additionally, configuring DynamoDB Autoscaling ensures that the provision capacity adjusts based on demand, optimizing cost further. Purchasing Savings Plan in Cost Explorer can provide additional cost savings. Option C. Use Provision Capacity Mode, purchase Saving Plan in Cost Explorer. Provision Capacity Mode requires specifying the desired read and write capacity units upfront, which may lead to over-provisioning and higher cost, especially considering the bursty nature of the application's reads activity. While purchasing Saving Plan can provide cost savings, it may not fully address the fluctuations in demand, so this one is also not the correct answer. Option D. Deploy DynamoDB Accelerator, use Provision Capacity Mode, configure DynamoDB Autoscaling. This option combines the benefit of DynamoDB Accelerator for read performance improvement with Provision Capacity Mode for predictable cost. DynamoDB Autoscaling can help adjust provision capacity based on demand, ensuring that the capacity is sufficient to handle workload spikes efficiently while minimizing cost. Considering the bursty read activity and the need to reduce cost while maintaining performance, option D is the most suitable recommendation. Question number 4. A company has a Windows-based desktop application that is packaged and deployed to the user's Windows machines. The company recently acquired another company that has employees who primarily use machines with a Linux operating system. The acquiring company has decided to migrate and rehost the Windows-based desktop application to AWS. All employees must be authenticated before they use the application. The acquiring company uses Active Directory on-premises but wants a simplified way to manage access to the application on AWS for all the employees. Which solution will rehost the application on AWS with the least development efforts? Option A. Set up and provision an Amazon Workspaces virtual desktop for every employee. Implement authentication by using Amazon Cognito identity pools. Instruct employees to run the application from their provisioned workforce's virtual desktops. This option involves setting up Amazon Workspaces for each employee, which can be complex and may not be the most efficient solution. It also requires implementing authentication using Amazon Cognito identity pools, which add additional complexity. So this is not the correct answer. Option B. Create an auto-scaling group for Windows-based Amazon EC2 instances. Join each EC2 instance to the company's Active Directory domain. Implement authentication by using the Active Directory that is running on premises. Instruct employees to run the application by using a Windows remote desktop. This option involves setting up Windows-based EC2 instances and joining them to the on-premises Active Directory domain. While it allows for authentication using existing Active Directory, it requires managing EC2 instances and remote desktop access, which may not be the simplest solution. So this one is also not the correct answer. Option C. Use an Amazon AppStream 2.0 image builder to create an image that includes the application and the required configurations. Provision an AppStream 2.0 on-demand fleet with dynamic fleet auto-scaling policies for running the image. Implement authentication by using AppStream 2.0 user pools. Instruct the employees to access the application by starting browser-based AppStream 2.0 streaming sessions. This option involves using Amazon AppStream 2.0, which simplifies application delivery by streaming it to users' devices. It allows for authentication using AppStream 2.0 user pools, which simplifies the management of access. Employees can access the application through browser-based streaming sessions, making it user-friendly. Option D. Refactor and containerize the application to run a web-based application. Run the application in Amazon Elastic Container Service on AWS Fargate with step scaling policies. Implement authentication by using Amazon Cognito user pools. Instruct the employees to run the application from their browsers. This option involves refactoring and containerization the application, which requires significant development effort. While it leverages Amazon ECS on AWS Fargate for container orchestration and scaling, it may not be the least development effort compared to other options. Considering the requirement of the least development effort, option C is the most suitable. It leverages Amazon AppStream 2.0 for simplified application delivery, provides authentication using user pools, and allows employees to access the application through browser-based streaming sessions, minimizing the need for additional step or development efforts. So the correct answer is option C. Alright, so this is it for today. Thank you all for attending today's class at 591 Lab. We hope you found the material informative and helpful. Remember, practice is critical to mastering any new skill, so review the course content and keep practicing with 591 Lab help and support. If you have any questions or concerns, please don't hesitate to contact us. We appreciate your participation and look forward to seeing you in our future classes. Have a great day.